adding and subtracting polynomials. And we're going to take a look at what it's adding and subtracting polynomials similar to. Well, I'm going to tell you that it's similar to combining like terms. But before we get into some of that, we need to do some definitions of polynomials and maybe some of the terminology that's associated with it. So, first off, let's talk about a monomial. A monomial is when there is only one term, and that means that the term also has to have a whole number exponent. So an example of this might be 3x, might be -5, it might also be y squared. These are all examples of one term, and these one terms are called monomials. It's a type of polynomial. Mono means one. Okay, let's take a look at something called a binomial. Bi meaning two in Latin tells us that we have the sum of two monomials, or two terms. So that might be something that looks like this. It could be x squared plus 5. We could have y squared plus y. 3 minus x. These are all examples of what some binomials may look like. Now a trinomial, by definition of tri, from Greek meaning tria, which means 3, that's where we get the sum of three monomials. An example of this would be x squared plus 3x minus 2. So again, here are some samples of what these types of polynomials are called. Anything that is 4 terms or more is just labeled as a polynomial. They are all considered polynomials, but the first 3 have special names. So it's good to know them in case you come across them in word problems so you know what they're talking about. Now, one of the things we have to remember is that we have to learn to write the terms of a polynomial in descending order according to their exponents. The reason for this is it just helps us to be able to talk to each other about our solutions and not cause as much confusion. For example, if I was looking at this particular polynomial, which is x to the 5th plus x to the 4th minus 2x to the 3rd plus x squared minus x plus 2, if we all have them in descending order by exponents, which you can see here is 5, 4, 3, 2, 1, and 0, that way we're always in the same place. Now some people might not remember that there is an x to the 0 out here, so that we can see that it is in descending order, because we know x to the 0 is 1 and 1 times 2 is 2. So there's always a variable in every term, whether we see it or we don't see it. So it's important to do it that way. That way it just keeps things smoother. Otherwise we'll be dealing with many variations and combinations and not getting past that. Okay, so let's kind of practice putting them in order of descending power of the variable. So here we have 9 plus 3r to the 3rd minus 5r to the 6th minus r squared. So let's kind of take a look at that. And we know that -5r to the 6th goes first because that's the largest value of the exponent, followed by a positive 3r to the 3rd minus r squared plus 9. We'll do it one more time here. Here we have 3x plus 3 plus 4x to the 7th minus 4x to the 6th. Again, we look for the largest exponent, which here it is at 4x to the 7th, followed by 4x to the 6th plus 3x plus 3. And again, it's just a habit to get into. Now let's talk about adding and subtracting of polynomials. We'll deal with adding first. And here I have two polynomials, 5x squared plus 3x plus 4 plus 3x squared plus 5. Now, there is what we call the horizontal method. Horizontal method tells us to just take all the terms and put them in descending order and then combine like terms afterwards. If we did that, we would start out with 5x squared because it's one of the largest ones, and it has another one right here, 3x squared. So we'd add that. Next, we would put plus 3x because again, we would put them in descending order, and then 4 and 5. And those, it doesn't matter which one goes first because they both have an exponent of 0 with their x. Same thing here, it didn't really matter which goes first. Then we're going to combine like terms. So here we have two sets that are alike. 5x squared plus 3x squared is 8x squared. Bring down that 3x. 4 plus 5 is 9. So that's one way that we can go about adding polynomials. Another way is the vertical method. It's where we put the terms in columns and then just combine like terms. What we would do is take the first polynomial, 5x squared plus 3x plus 4, and then when we go to write the second one, we would write down what it matches to or what its like term is and write it underneath it. So 3x squared would go immediately under 5x squared. The 5 would go under the 4. And then we would add vertically. 5x squared plus 3x squared is 8x squared. we would bring down this 3x because there's nothing else to match up with it, and 4 plus 5 is 9. So again, you're going to pick a method that works best for you, whether it's the horizontal method or the vertical method. Now, let's try it one more time. I'm going to use the vertical method here. And before I jump in, I always want to evaluate what's happening. So when I look at this first polynomial, I have a 4, 2, 1, 0. In the second polynomial, I have 4, 3, 2, 1. So this one has a third power monomial in its term. This one doesn't have it. So when I go to write this first polynomial, I'm going to leave a space. 2x to the fourth, leave a space, minus 5x squared, plus 4x, plus 5. What this does for me is when I go to put them underneath, this one goes 5x to the fourth, matches here. This plus 7x to the third is just going to sit here with nothing above it, but I will be in descending order, so I don't need to rewrite it afterwards. Negative 2x squared will be underneath negative 5x squared, and negative 2x would be under positive 4x. We're going to add them together. 2x to the fourth plus 5x to the fourth is 7x to the fourth. Bring down that 7x to the third. Negative 5x squared and negative 2x squared is negative 7x squared. Positive 4x minus 2x is 2x, and then plus 5. We're going to try it again, but we're going to look at subtracting. Subtracting polynomials is a little bit different, okay? And what I mean by that is that there are two different methods again. We can do the horizontal method. We're going to rewrite the original problem, but when we write the additive inverse of the second polynomial as we remove the parentheses. Remember, the additive inverse is we're talking about the opposite signs of what's inside. Now, method 2, which is the vertical method, we're going to do the same thing, working vertically, and we're just going to distribute that negative sign as we rewrite it vertically. So let's take a look at this problem. 5x to the fourth plus 4 minus 2x squared minus 1. And let's do the horizontal method. So according to the horizontal method, I'm going to write down what I see at the first polynomial. And this second one, because of this subtraction sign, I'm going to take the additive inverse of 2x squared minus 1. That should be negative 2x squared plus 1. Now remember, in the horizontal method, we want to put things together that are alike. So we need to get these two together. So we're going to rewrite this 5x to the fourth minus 2x squared plus 4 plus 1. These two terms are alike, so those are the terms that will get grouped together. The other will stay apart. So 5x to the fourth minus 2x squared plus 5. Let's try it on this long one. Let's try the second method, the vertical method. And again, before we do the vertical method, we always want to jump and take a look and see what happens before we get started. Here it goes from 4, 2, 1, 0, 4, 3, 2, nothing, and then 0. So we want to make sure that we leave a space to get that third power in there. So let's start out by writing down the first one. Negative 4x to the fourth, leave a space, plus 5x squared plus 3x plus 5. And then when we go to write the second one, we're going to, what I said is distribute the negative. So this negative is going to get distributed to everything inside. In other words, remember, this negative represents a negative 1. So we're going to multiply everything times negative 1 and see what sign that really is going to be. If I do that, this then, instead of negative 6x to the fourth, becomes positive 6x to the fourth. Instead of positive 2x to the third, negative 2x to the third. Instead of negative 3x squared, positive 3x squared. Instead of positive 7, negative 7. This way, when I go to add them all up together, I can go back to what I did before. Plus 6x to the fourth minus 6x to the fourth. Together, that's 2x to the fourth. Bring down the next term. And again, I'm already in order. 5x squared plus 3x squared is 8x squared. Bring down the next term, plus 3x. Positive 5 minus 7, negative 2. And then we're in order and we're combined. So we can kind of look at adding and subtracting polynomials as combining like terms, but just make sure that when we're talking about subtracting a polynomial, that you're distributing a negative or taking the additive inverse of that polynomial.